Hello everyone, this is Shailesh Damle from Shimadzu Middle East and Africa Dubai office. I welcome you all for Shimadzu's webinar on an introduction to Shimadzu's forensic solution. During 1960s and 70s, the hair was analyzed for investigation of heavy metals by atomic absorption spectroscopy. At that time, analytical techniques were not sensitive enough to analyze organic compounds, particularly drugs from hair. In 1979, the first research article was published regarding the analysis of hair from heroin users. As we are aware, morphine is a metabolite of heroin, and morphine was found in the hair of drug addicts. It was also found that the concentration of drug varies along with the length of the hair. The concentration which could be correlated with the time period of abuse. But nowadays, sophisticated techniques like GCMS, LCMS are commonly used, and there are reported methods for analyzing drug of abuse from the hair of the hair addicts. But during last few decades, the tremendous research work has been done to investigate different drug of abuse and their metabolite in different types of biological fluids. The samples like saliva, sweat, and hair. In several countries, biological samples other than urine are being explored for applications such as workplace drug testing, providing information about chronic intoxication, awarding a driving license, general clinical toxicology, sometimes in criminal justice, in the treatment of addicted patients, postmortem toxicological studies, and sometimes some drug-facilitated crimes. We will discuss in details about tools and techniques which Shimadzu provides to detect various chemicals and the metals in different body fluids in coming few slides. Now let us see the topics which we are going to discuss today. To start with, we'll discuss about some important definitions, the real challenges faced in the field of forensic toxicology. We have noticed that there might be some wishes and unmet analytical needs which we need to discuss. I'll try to discuss the solution which Shimadzu provides with the help of LCMS, GCMS, ICPMS for metal analysis. We have seen that during pandemic, the need of automation and high throughput in each and every sector. Shimadzu had noticed that even before, and we had introduced our high throughput analysis as well as automation in the field of analytical instrumentation. I'll, I'll discuss some of the automation and high throughput analysis in today's presentation. We have complete solution for cannabis analysis as well. I will discuss it in little brief. The human body today is more exposed to chemicals, drugs, radiation, pesticides, and other substances than ever before. So the toxicological analysis has a lot of importance. Under the broad heading of toxicology, there are multiple fields of toxicology. I'll present today in next 30 minutes or so about Shimadzu's solution for forensic toxicology. Now let us see some important definitions. What is forensic toxicology? Forensic toxicology is a science of detecting and identifying the presence of drugs or poisons in a body fluids or in organs. Then what is dose? So dose makes the poison. This is the fundamental principle of toxicology, but the actual study is much more complex than this simple statement. Now, what is poison then? The definition of poison is any substances that when taken into sufficient quantities cause harmful effect or deadly reaction. But how much is too much and how less is too little, that is very important part. And that is where the sophisticated instrument like LCMS, GCMS play a very important role in toxicological analysis. Now, there are typical samples which are analyzed during toxicological analysis. This is based on what is the desired output of that particular test and what exactly the analysts want to see from that test. Toxicological analysis is not straightforward. There are certain challenges due to large number of compounds to be screened and to be analyzed. Based on the requirement, a typical sample need to be selected for the analysis. Now, the detection of drug and pharmaceutical in blood fluids initially done by screening and then confirmation analysis followed by quantification. Some instruments which are capable for screening as well as quantification, but it is not necessarily be the same. Sometimes one instrument is capable of doing only screening and one is good for quantification. But sometimes some tools which are capable of doing screening, identification as well as quantification. These are the different categories of drugs which are normally monitored. Opioids, antidepressants, sedatives, and other prescribed and illicit drugs are the typical target for toxicological analysis. Now, let us discuss about some practical issues and the wishes and some challenges faced by the analytical chemist who is engaged in routine forensic toxicological analysis. As we are aware, there is a need to check thousands of compounds and their metabolites. Lab cannot procure all the standards and store them. It is rather impossible to procure all the standards and store them in solution. It is not a bad idea to have a screening without authentic standard. However, lab cannot afford to compromise with the quality and the reliability of data. Laboratory needs to have the highest level of confidence on the data which has been generated. During pandemic, we had very difficult time when many people cannot gather together in the lab. At the same time, we had challenge to analyze more number of samples with a limited staff. There was a need of automation as well as high throughput systems. The automation basically which reduces the human efforts and avoid possible infection. For all these, Shimadzu has solution. We'll discuss all these solutions in coming slides. Shimadzu provides a complete solution with our HPLC, GCMS, LCMS for illicit drugs and overall forensic toxicology, and ICPMS heavy metal analysis. There is a high chance user may encounter challenges with known compounds which are newly added or not in the scope of LCMS database, which we are going to discuss in coming slides. QTOP can help you to identify the unknowns. Shimadzu's MS instruments are based on our UFMS technology, which is ultra-fast MRM, ultra-fast polarity switching, and ultra-fast sensitivity. UFMS brought revolution in the field of mass spectroscopy. Shimadzu introduced their first LCMS triple quadruple system in the year of 2010 with our UFMS technology. Shimadzu entered in triple quadruple market little late than our fellow competitors, but Shimadzu entered with our latest technology. It was the first triple quadruple instrument in the market to achieve the world's fastest scanning speed of 15,000 masses per second and 15 millisecond polarity switching time. Following years, Shimadzu launched GCMS, LCMS and ICPMS series instrument almost every year with UFMS technology. Every time when we launch our instrument, the instrument came up with improved specification. Currently, LCMS is with 30,000 masses per second scanning speed and 5 millisecond polarity switching time, which is currently highest in the market. Let us discuss now how UFMS is useful in the field of forensic toxicology. Shimadzu provides database in various application fields. We have many databases for forensic toxicology as well with our LCMS and GCMS. I will explain in the details about few method packages and their applications today. Yes, before we go ahead, you might have one question. What is database and what are the method packages? Database or method packages are nothing but the collection of all the method parameters and compound details in a single package, including retention time and other compound details. Basically, method packages make it easy to set up analysis. The chemist does not need to put a lot of efforts in method development and method standardization. Sometimes even user does not need to procure costly standards and use it routinely. In method packages, there are multiple methods given as per the different categories of compounds and their different chemistries. As I said, we have multiple method packages and databases. I will discuss 4 of these today. Method packages cover thousands of compounds and their metabolites. The method package of drug of abuse is one of the early days method packages which cover almost 200 compounds registered with ready to use method. The method contains HPLC condition, product and scan, MRM transition, and spectral database. The forensic toxicological database built on two different separation methods. One is with ODS method and another one with biphenyl method. In all, these two methods cover almost 2,500 compounds. Shimadzu also supplies the datasheet for all those 2,500 compounds with the details of CAS number, retention time under the specified analytical condition, molecular formula, monoisotopic mass, compound class, and whatnot. What else is required? I think this is sufficient enough to set up the method. Additionally, this database has a data with the different collision energies, which will help to create MRM spectrum, which is powerful tool basically to identify compounds with library match score. Going ahead, the rapid toxicological screening system is one of the simultaneous analysis method it can perform even by unexperienced user. This rapid method covers almost 230 compounds, which includes drug of abuse, psychotropic drugs, sedatives in less than 15 minutes runtime. This gives the total solution including the semi-quantification without authentic standard. The Quacher-based sample preparation method, which has a calibration curve information for all the method compounds. The internal standards are available, which are good for semi-quantitative analysis. With the help of Lab Solution Insight software, which is designed to process multi-component analysis and process data effectively. All the analytes results can be seen in a single window, which is good for interpretation of the results. This is now standard supply of Lab Solution Insight with our new LCMS as well as GCMS. Now, going ahead with another method package, rapid toxicology screening system is more than one method package and for rapid screening. Another one is DPIMS is an optional kit for LCMS 8045, 50 and 60. DPIMS is a direct probe ionization mass spectrometer. Basically, this method package provides MRM based simultaneous analysis for approximately 64 compounds from blood and 77 compounds from the urine. These basically compounds the typical drugs for forensic cases, including illicit drugs, narcotics, and psychotropic drugs. We have developed many application nodes as per the databases. This is one of the applications for multi-target screening for amphetamines, opioids, and benzodiazepines with LCMS 8060. The Quacher-based sample preparation method was used for extraction from blood. This application was developed not only to reduce the false reporting but also to use as a routine toxicological analysis by considering the simple sample preparation and a better separation for the compounds with a diverse chemical nature. The QTOP LCMS 9030 is a quadrupole time of flight detector. QTOP basically comes in the category of high resolution mass. QTOP has a ultra-fast acquisition rate which allows you to identify and quantify more number of compounds with more confidence. QTOP is used for screening and quantification for more than 2000 compounds. The current LCMS MS triple quadruple spectrum library can be used here with a QTOP for pattern matching with LCMS 9030. The important feature is to identify unknown compounds. The unique data-dependent acquisition with find algorithm is very useful for unknown identification. Now, you are quite aware that QTOP is a tool of identification. This application shows how QTOP is useful for expand the capability of routine toxicological screening by reducing false positive reporting. Now, I showed you various method packages for LCMS and QTOP. Let us now see some databases and method packages for GCMS and GCMSMS. I'll present today the three different method packages and databases for GCMS and GCMSMS. GCMS Forensic Toxicological Database Version 2 has a spectral database of 2200 compounds. This database is with GCMS single cord. The GCMS single cord based method, which has details of gas number, molecular formula, molecular weight, retention indices, etc. Retention indices are very useful to adjust retention times automatically. This function is called as a ART function. Since RT information is given in the database, the compound can be identified by retention time as well as with a mass spectrum. Going ahead, the Smart Forensic Database for GCMS-TQ, which covers almost 486 compounds. The compound details as similar as GCMS single cord, which given here. The smart MRM, since it is a triple quadrupole, automatically determines the optimum runtime measurement and different settings, which creates a sensitive method for analysis. The MRM based method is created and the retention times information is always given with the database. So the MRM method is created based on the retention time information for target compounds by using ART function. Going ahead with QuickDB forensic GCMS MS based database. The GCMS QuickDB forensic database includes information for sample preparation, analysis, data processing of 68 toxicological drug components, which are common in toxicological cases. Again, here the simple quencher method is used for sample preparation. As I said, even the first time users can prepare sample and do the analysis. In addition to analytical conditions such as optimize MRM transition, the database also includes retention indices, calibration curve information, and other data for data processing parameters as well. This semi-quantitative method, which does not require any standards for analysis, it uses only 6 deuterium label internal standards, which are mostly behaves almost similar as registered compounds. So the quantification is possible only by the comparing the internal standard response. It does not require any other standard for analysis. So it is quick, fast, and semi-quantitative analysis for toxicological samples. This is one of the applications for GCMS. This particular application was developed on GCMS TQ8030 for the analysis of opioids using isotope dilution method. This is one more application which was developed by Smart Forensic Database for toxicological substances in whole blood. The liquid-liquid extraction was used for sample preparation. With the help of forensic database, the simultaneous scan measurement method was created for the analysis. Scan method along with MRM is useful for identification of compound with the help of the MS spectrum, which is generated with the scan method. We have seen different method packages and databases for LCMS and GCMS. Now let us discuss about automation and high throughput analysis. We have seen that during pandemic time, there was a need of automation and high throughput in almost each and every sector. As I said before, Shimadzu had noticed it even before that, and Shimadzu had introduced the automation and high throughput tools in the field of analytical instrumentation well before. Now let us see what are the different tools and techniques for automation as well as high throughput analysis. CLAM 2030 is fully automated sample preparation module for LCMS. This is based on Shimadzu's very extensive experience with the clinical examination system for blood coagulation analysis. User can simply place blood collected tubes in the CLAM module position here, and CLAM automatically performs everything from sample pre-treatment to analysis. This kind of automated system does not require any human attention. User can load it, fire it, and forget. User will get all the results at the end of the analysis. The module on the left hand side is a CLAM 2030. Remaining part is like a conventional LCMS system. CLAM 2030, which connects robotically to LC autosampler. User has to load the samples in the CLAM module The CLAM integrates entire workflow from sample preparation to data acquisition and data processing as well as reporting. The two biggest advantage of this module is that user does not need to get exposed to the sample for longer time. And after the analysis is finished, the sample will be discarded the closed container which is placed at the bottom of the CLAM module. Another important advantage is that it increases your data reproducibility drastically. As it is known fact and it is accepted that most of the error in the analysis are due to the pre-analytical steps. CLAM 2030 has a solution for all of these. CLAM 2030 is suitable for biological samples like plasma, serum, blood, urine as well as saliva. So that is the reason why this is perfectly suitable for routine clinical as well as toxicological laboratory. Shimadzu has developed many clinical and forensic methods on LCMS with the CLAM 2030. We discuss few of the applications in a coming slide. As CLAM is suitable to handle different body fluid, many applications which were developed on conventional LCMS have been transferred to CLAM. This application basically talks about measurement of 245 illicit drugs and medical compounds from blood, plasma, and urine. This automated method gives high confidence in compound identification as well as it gives very good accuracy. CLAM automation decreases the time required for the analysis by overlapping sample preparation with data acquisition. This enables users to work on other important tasks. Going ahead with another application, the multi-targeted screening method, which we have seen in LCMS, which has been converted into automated method here with CLAM 2030. Lab Solution Insight works with main lab solution software, which is useful to handle multi-analyte data. The flag function helps to quickly identify the sample or any analyte in the sample which is failing as per the predefined limit. Sample may be failing due to change in retention time, concentration, ion ratio, and so on. Lab Solution Insight software is designed to process multi-component data. This software is also useful in other multi-residue analysis field like a food safety. Let's see one more application on CLAM 2030. By now you must have noticed that many routine LCMS applications, especially samples with biological fluid matrix, have been converted with this automated system of CLAM 2030. This is another automation with very high throughput. LDTD is laser diode thermal desorption system. This source is a direct ionization source which gives exceptional high throughput. The speed of analysis can be as low as 4 seconds for one sample. Unlike LCMS, LDTD does not require mobile phase. So it reduces background noise during measurement. So the analysis has very high sensitivity. I said in previous slide that LDTD does not require mobile phase. However, you can see that HPLC is still connected to the instrument. This is because the same system can easily be used with LDTD and without LDTD as a conventional LCMS system by just clicking in the software, and almost there is no need to change in hardware. Let's see the application of LDTD. We have developed fast quantification method for 8 compounds in a sample in less than 9 seconds. With LDTD, the lab can improve the throughput to the maximum. Even with high throughput and high speed, system still maintains the better sensitivity. All these compounds have been detected here in ppb level. We are aware that few metals are also toxic and need to be monitored and quantified. Shimadzu has a method for quantification for trace metals in blood by ICPMS 2030. This can detect and quantify the trace metal in sub-ppb level. ICPMS 2030 has unique capability to work with a lower consumption of argon. Due to less consumption of argon, ICPMS 2030 has the lowest running cost. Shimadzu has complete solution for cannabis analysis as well, which covers broad range of application from potency testing and terpene profiling. Also, we have a solution to check the contamination from pesticide, residual solvents, heavy metals, as well as mycotoxins as well. Now, coming towards the end, let us see the wish list which I talked about earlier in the presentation. Did we get any solution to your wish? Yes, we found the answers. We have rapid toxicological screening system for LCMS and quick DB forensic for GCMS, which does not require any authentic standards. We discuss about the spectral database over 2000 compounds and other database which gives high confidence in identification as well as in quantification. We discuss about the automation of CLAMP 2030 and LDTD, which not only increases the throughput but also reduces the human efforts. There are truly fire and forget kind of system which can work around the clock to generate reproducible and reliable results. I sincerely thank you all on behalf of entire Shimadzu Middle East and Africa for your time today and attention. Thank you very much.
Excellence in science. Shimadzu.